Okay. Giuseppe, could you try mic check?
Starting to feel like we caught everybody, stepping away from the computer just before the session started. So since Giuseppe hasn't responded, Yali, could you also do a microphone check, please?
Could you hear me well?
We can hear you. Thank you.
Thank you.
Can you hear me? This is Giuseppe.
Giuseppe, you're a little bit quiet.
Okay. Now it's better.
It sounds like you're talking to an open air mic.
Let me change the setting.
And hello, Linda. If you could do a microphone check while we're waiting to start, that'd be great.
Can you hear me?
Loud and clear. Thank you.
Okay, good.
All right. We're 2 minutes into the session. Sue, do you want to kick it off, or Jeff, you want to kick it off?
I'll go ahead and kick it off today. Go to the folks. Welcome to the Wednesday session of IDR. We've got an hour. If you've not read the note well, please do that. Care, will you show the next slide, which is the agenda? Our agenda is close for an hour, so folks, please be tight. If we get some more time at the end, we'll open it up to question. If not, Waymo, you're first. Go ahead.
Hello, everyone. Today I'm going to present the BGP flu spec for SR phase 6. Next page. We'll just give a quick review about the document. So for IP phase 6 packet head for SR package, it has special structures. For example, its destination is a segment ID, which consists of locator field, functions field, and arguments. So for this special structure, we define 2 new component types. So one of the type can consist a list of operators with values to define matching conditions on this special field, such as locator field, function field, or arguments field. So next page. So for this latest version, we just made some editorial changes. Next page. So we would like to welcome comments, and also we would like a request for adoptions. Yeah, that's all for me today. Thank you.
Cool. Joel, you're on the mic.
Thank you. I had apparently not looked sufficiently closely at this draft. If you're trying to point explicitly at the lock field and not encoding the length of the lock field in this spec, then interpretation of this piece of flow spec requires processing and using other routing information to know how long the lock field is?
Yeah, good question. Thanks. So in fact, because these are actually just a very brief review, we have for each operator we have a value. So those lengths for locator and the function is encoded in the length in the value of in the value field in the value. So can you go to previous slide? Previous one, the picture. Here we just give details about operator. In fact, operator has associated with a value. So those length field is given in that value. We have structure
Okay.
there. Yeah, thank you.
Okay. So the length, the length, well, it's not in the field type, is in the value. That's good enough. Thank you.
Yeah, yes.
Super. Jeff?
Hi, Mo. My question to you is, this is obviously targeted for current SRv6 related stuff. How do you foresee this interacting perhaps with the work ongoing in Spring for the more compact formats? Are you expecting this to be a logical format that you're expecting to carry to the new compact formats? Or do you think that you'll need a new flow spec for each of those?
Yeah, that's a good question. I think this because we take the uncompressed. I think for compressed one, because that structure maybe have more information or have additional information for compression. So in that case, we need a further extension for compressed seeds, right?
That is my question and one of the possible outcomes. I think the input I would give as an individual contributor rather than a chair is that one of the things we know about the SR related stuff is that the differing formats are going to be a big challenge, and I think we should understand what we're looking to get out of flow spec for the different formats before we choose any specific draft towards it. Not so much that your draft doesn't solve the SRv6 problem, more that we may want to solve the more general problem.
Yeah, I think the first step is focus on the uncompressed one, because for compressed one, they are still working in progress because there are number of proposals for compressing the seeds. So different solution or proposal for compression, they may have different information attached or added into the destination or seeds, or some of them just will update the header, some fields, open field and flex fields.
Understood. Thank you.
Joel, you're next.
Sorry, I pulled back up the draft and looked. While I get how the length in the value type works for the lock, how do you find, you actually want to be able to explicitly test the func, and actually there are multiple problems with explicitly testing func separate from lock. Among them, that it is not actually required that they have meaning, that the encoding is constant across things. That's not what's required by network programming, and you don't know where the lock is. The length of the value field won't tell you where in this thing the lock is, and it is not required that it be at a constant offset for all SIDs used in a given domain, even within SRv6. It could be, but it's not.
Yeah, that's a good question.
I don't think this works.
This because we just provide this kind of component, and then use this one. The user or application will define those operators, and then the user or application will have more information about the size of locator, because for some of because those applications will target for some flows, traffic flows, and then for those traffic flows, they will know, they have more information about the locator and the function they're
But
interested in.
you can't process this without prefix specific information from elsewhere in the routing system, not just general config information. I wouldn't care if it required general config information, but you need to actually know, for this lock, I look at this many bits to see that that's the func. If I have this prefix on the segment, on the SID, then I look at this many bits. And that's just not the way, even, I mean, FlowSpec has lots of problems, but I don't think you can do what you're trying to do here the way you've laid it out. I think you need to go back and look again at the RFC on network programming and on the encodings for how things actually get transferred. Remember that, for example, the standards for the values of func are not actually standards for the values in the packet. They are only standards for the values that get encoded in the routing protocol that tell you what the meaning of the SID is. So you don't even know what the meanings of the func bits are unless you've looked in routing for the specific lock, and it's encoded separately for individual locks. So I think that the SRv6 network programming is much harder to filter if you want to separate filters. If you just do it as a prefix on the SID, sure, it works. I can't argue with that. And the length of the value will tell how many bits to test. It works. But if you want to separate out the func or the args and test them, it's not even clear it's meaningful as a test, and it's not findable as written.
Joel and Waymo, I think this is a great thing to actually detail on the list, Joel. Waymo, it might be a really good thing to have a discussion on this and confirm it before you ask for working group working group adoption. Would that be okay? Because we're gonna run
I know
past.
you're short of time. No problem.
Okay. Yeah.
And
yeah,
also,
we'll go through this.
Joel and Waymo, I think that the discussion would also be valuable either on IDR list, because we're looking at the limitations of FlowSpec. You may find that FlowSpec v1 or just proposal for expanding FlowSpec v1 may take us into v2, which may provide us additional aid. So I really would like to see this on the list because I think it's beneficial for our general FlowSpec. Thank you both. If we have additional time at the end, we'll open this up. Joel and Waymo will come back to this.
Okay,
Thank you so much. Thank you, Waymo. Next presenter, Linda, you've got 2 sessions.
Okay, so here I'm going to introduce a new NLRI address family for the 5G edge computing services. Next slide, please. So we presented this in 109. There were quite a few questions on the list and also during the discussion. So I just want to recap what we discussed. So basically, there was an assumption that all those edge computing servers, they are in the local data network close to the 5G core network. And the multiple servers for one application. And the application prefer to use Anycast address simply because it make it easier for deployment. So they don't have to readjust addresses for the application when they want to move a service from one server location to another. With Anycast address, the network itself being leveraged to distribute the traffic to different edge nodes. So the thing about in our network itself, network itself has been very good in using the routing distance to compute the best path, to select to the best path. And we also have TE, traffic engineering, taking bandwidth into consideration. However, for this kind of environment, the bandwidth information and the routing distance might be similar. So there's another attribute being introduced, which is the running environment that load information. Those applications themselves are registered application services, not just any service attached to the network. Only the application that need network to further optimize the distribution among different locations. So we introduced a new NRI and sub-TLV to carry those information so that can help the ingress node to choose the optimal path to the egress router. Next page, please. Okay, so during the 109 and the mailing list discussion, there were three issues being raised, three major issues being raised, right? So first one is how to select the optimal egress router based on the information received. Second one is how the ingress node keep the packet from one flow to the same server. Third one is when the UE move from one cell tower to another cell tower and being anchored to a different session, PDU session, or they call it, which is part of the UPF, user plan function. Then they will go to a different ingress node. How that flow can be stick to the original server. Okay, so next page, please. So this meeting, I just want to clarify those issues. So first of all, for the path selection, there's assumption here, right? So only for the registered services, there's the application controller, which is identified in the 3GPP 748 project. The application controller will tell the network which services they are interested for network to optimize the forwarding. With those information, appropriate ACLs can be created on the ingress node and on the egress node, which service to collect. And there's a BGP compute plugin that can compute the optimal path or best path with the information about the routing status, in addition to the routing distance and the bandwidth information, if TE is considered. So that's the assumption. So this for the path selection, that's basically we'll be able to take the application metadata input into consideration, so that when a destination has 3 next hops, R1, R2, R3, and they can choose to the optimal one. And in terms of forwarding, when the BGP compute download the forwarding table to the forwarding plan, the forwarding plan will use the flow affinity feature to support to be able to make one flow goes to the same path. This feature is supported by most commercial routers. And when the UE moves to a new cell site, and then the traffic will ingress from a different ingress router, we have a draft in 6-man to show how do we use IPv6 to stick to the same egress router. And also, if the LDN is HRv6 based, that approach has been described very clearly in the 6-man APN 6 to show how the SRv6 is used to stick to the original path. Okay, next page, please. So in the for the app metadata information propagation, is not to be distributed to every node. And the scope of the propagation can be we can use the RFC 4684 to constrain the distribution. But there could be application servers, many of the services needed. So this could also be statically configured. The application server ID, which is the Anycast address, and then with the interested routers. Next page, please. So here, those are the main sub-TLVs we propose. One's the NLI, pass attributes for the application metadata. And today we only specified the 4 sub-TLVs. One is the load measurement, and one is the capacity. Another one is the preference. Those information can be either actually downloaded or exchanged between the application controller to the egress router, or computed by the egress router. So those are out of the scope, how the egress router get this, derive those information. But those are the NLI needed to carry those information. In the future, maybe more application relevant data can be included here. But for now, we are asking for working group adoption just for those proposed NLI and sub-TLVs. That's it. Thank you very much.
We've got a little under 2 minutes. Any questions for Linda? Linda, you're on to your next presentation.
Oh, okay. So this is the SD-WAN Edge Discovery. This actually will be a very short presentation. Thank you very much to the working group for the valuable feedback. And we have cleaned up the draft. And so I just want to give you an update. Next page, please. So this is what we discussed in IETF 109. Basically, we took the tunnel in cap draft, the mechanism described in the tunnel in cap draft, and now it's probably on the queue to IFC now, using the separating the underlay tunnel property advertisement from the client. So the client basically used the extended community to describe the tunnel type, and also use the color to correlate with the underlay property. So there will be two types of update, right? One is the client, one is the underlay. Next page, please. So we cleaned up a little bit here. Basically, if IPsec IPsec Security Association has been pre-established. So instead of attaching all the IPsec related parameters, we just include the IPsec IDs, and those IDs are pre-established. And if those IPsec has a certain inner encapsulation, we'll attach the proper tunnel encapsulation sub-TLV, which is already described in the tunnel encap draft. So I presented this on Monday to the IPsec ME. Just make sure those kind of configuration and those kind of method of carrying the information doesn't cause any problems with IPsec ME group. And people over there think this is a good approach. This is slightly different from the traditional IPsec configuration, which is always pairwise. You always have 2 end nodes, and you have to establish authentication. You have to establish all the related like traffic selectors, admission, and routing information between the 2 peer nodes. With BGP, with the route reflector, it scales much better than the pairwise. When you have, especially when you have a large network, And also that with BGP, you have a raw reflector already connected to all the edge node through secure channel. So the authentication is already done before even this being established. Before this message to be exchanged. So that's a good news from the IPsec NE group. Next page, please. So, but for the IPsec Security Association, if it's needed to be exchanged through a BGP update, they can also include it here with detailed information like the key sub-TLVs, nonce, and proposals, transform, all the detailed attributes needed by IPsec. They can also be included as a sub-TLV in the tunnel exchange. Next page, please. So with hybrid tunnel, which can include both MPLS path and IPsec path, this NLI is introduced. Basically include the color, include the site type, because for HD1 deployment, some sites can be far away. It's not like controlled, like MPLS, everything is within the wall. So the site type can be simpler, just the node ID itself, be able to identify the precise location. There could be in a more diverse geographic location that you need to include the geolocation information sub-TLV to indicate the accurate, precise geolocation. And we have color to correlate with the client update. Next page, please. So we think that this draft is clean enough and answered many questions from the working group, and we are ready for working group adoption.
Super. Any questions for Linda? Thank you so much, Linda.
Great, thank you.
And we got 4 minutes back. And our next presentation, Giuseppe.
Hello, everybody. Can you hear me okay?
Yes, we can hear you fine.
Okay. Yeah, this is an update about the BGP-SR policy extension for IFIT. The draft has been adopted during IETF 109. So next slide. Yeah, just a few words about the background and motivation. IFIT refers to data plane on path telemetry, in particular in situ ORM and alternate marking. And you can see the document, the relevant documents for these two methodologies. On the other hand, we know that an head-end may be informed about a candidate path by using BGP. And you can also see the relevant document. By combining these two, both on-path telemetry methodology and using these BGP capabilities, this document aims to define a new extension to BGP to distribute IFIT information together with the SR policy. In this way, the on-path telemetry methods can be automatically enabled. So next slide. Yeah, in this slide, we report all the changes after the working group adoption. In particular, we received some comments on list during the adoption call. Yeah, firstly, from Drew, he suggests to add more text about the error handling actions, the IFIT procedures, to start, stop, update the different IFIT features, and also the backward compatibility that need to be guaranteed. Another comment from Ketan was more about the types of steering that would be possible to be used for SR policies and how this is handled by the SRTM. Another comment from Gan was about the alignment with the SR policy and tunnel encapsulation attribute according to the IDR segment routing fee policy draft. Another comment from Mike was common to the companion draft in PCE regarding the possibility to consider different IFIT methods for each segment list. And we also added some consideration about that. And in the end, we added the new fields in the alternate marking mode to indicate if the measurement is op by op or end-to-end. Next slide. Yeah, in this slide, we summarize the main changes in the 01 version. The first one is about the specification of how happen the steering into an SR policy. Basically, it is the same as specifying in the Spring document on segment routing policy. So once the IFIT attributes are signaled through BGP, when the packet arrives at the head end, it may get steered into the SR policy according to the procedure defined in the Spring document. And IFIT methods can be applied, of course, if they are similar. Regarding all the possible cases of IFIT, we adopt in the draft a conservative strategy. So this means that in case of empty IFIT sub-TLVs or more than one instance of the same sub-TLVs, or if there are two conflicting IOM sub-TLVs, IFIT is not activated. So it's better to have a conservative approach if this is an optional functionality. Regarding the validation, as specified in the Spring document, this can be treated as all the other TLVs. So the validation can be added by the SRTM. The backward compatibility can be also guaranteed because if there is an implementation that does not understand IFIT sub-TLV, it can be simply ignored. And the same apply for error handling actions, because as described in segment routing fee policy draft in Spring, a BGP speaker must perform the syntactic validation of the NLRI and can determine if it is good, if it is malformed. And if there is an error, treat as withdraw is a good strategy to apply. And these, of course, apply also to IFIT TLV. Next. This is a quick recap about the draft. We updated the SR policy encoding structure and the IFIT attributes. You can see that the draft added the IFIT attributes at the candidate path level as a sub-TLVs. On the right, you can see the format of the general IFIT sub-TLVs and the detail of the different options sub-TLV that are currently defined, that are 5. Next. Yeah, in this slide, we have the detail of the in-situ AM sub-TLV, so that are 4 for the pre-allocated trace option, the incremental trace option, directly export option, and edge-to-edge option. All the fields, of course, are aligned with the in-situ AM draft in IPTN. And next. Yeah, this is the other sub-TLVs related to the alternate marking. As I said, we added 2 new fields, 2 flags, H and E, that indicated that the measurement is op by op or end-to-end. And this is also aligned with the relevant draft in IPv6 on data plane about alternate marking. Next slide, please. Yeah, we added some more consideration about the operations with IFIT attribute for SR policy. Basically, we referenced all the operations of segment routing key policy draft in IDR. So we just updated added some consideration, but the basic operations are the same. Since IFIT attributes sub-TLV are optional, they can be considered in the NLRI by a BGP speaker, but of course the implementation may ignore the unsupported sub-TLVs. Once the NLRIs have been acceptable, have been considered acceptable, including the FIT information, this can be propagated. Regarding the error handling and the validation, this must be performed to determine if they are malformed or invalid, but this is done by the SRPM, as also stated in the segment routing key policy draft. So next slide, please. Yeah, this is the final slide. So we are working, this work is in progress to make the draft stable. Of course, we welcome questions, comments to improve it and to go ahead. Thank you.
Any questions for Giuseppe? Super. Thank you.
Yeah. Thank you.
And I believe we still have one presentation more from Yali.
Yes, I'm here.
And I'm trying to get hold of the slides.
Okay, thank you.
Give me a second, please.
Yeah, sure.
Grab the presentation. I have them. Hold on.
Yeah. Can I give you the screen?
Yep.
So you got the screen.
Okay. This should be Yali. Do I have the right presentation?
Yes, but I cannot see the slide. Actually, the screen share is being started.
I see. Never mind. Give me a moment to go back to the screen sharing. Give it a second. Excuse the few moments of fiddling with this.
Mhm.
Okay, just a minute, you'll get the big screen.
Yeah, I can see.
I'll get you a
Let's
full
start.
screen mode. Can you go ahead anytime you want?
Okay, thank you. Hello, everybody. My name is Yali Wang from Huawei. So I'll talk about the draft to propose to define the BGP extension for advertising IFIT capability. Next slide, please.
Do you see it, Ellie?
Yes, yes. I think maybe it's a little bit delayed. Yes, thank you.
Okay.
So first, I am going to describe requirement and goals of this proposal, and then I'll introduce the definition of IFA's capability and two optional extensions. Next page, please.
Your next slide is showing.
Yes, I see it. So yeah, first of all, in let's start, the IFIT refers to a family of data plan on path techniques, including the in situ OEM and alternate marking. And I need to indicate that the IFIT capability of the devices can be manually configured one by one. So hence the deployment efficiency is low and manual configuration may be incorrect. So and when the IFIT capability of the network devices is changed, for example, the devices change it from the supported IFIT to non-supported IFIT capability. So the IFIT configuration on this device need to be modified. So based on this question and issues here, we propose a extension to BGP to advertise the tail node IFIT capability. So in this draft, we propose two optional methods. One is to extend to IPv4 or v6 address specific extended community. And another one is to extend to the BGP next hop capability. So here, I want to answer the question why we propose this two optional extensions. As I mentioned before, we need to prevent the information leakage, which means that we need to avoid the IFIT data leak outside of the IFIT domain, which may cause conflict and errors. And another reason is that we need to determine whether a particular IFIT option types can be supported by the tail node. It means that depends on the information, I can decide which kind of the IFIT option to be encapsulated in the ingress node. Yeah, this is the reason. Next page, please. So here we firstly define the IFIT capability format. As shown in the figure, it's formed as the 16-bit bitmap. And right now we give the 5 flags used to indicate different kinds of the option types, include the IOM and the alternate marking. Yeah, next. Okay, here, this is the first option extension. This is the extension to BGP extended community. So here we give the two scenario. Firstly is for the IPv4 network. So let's define a new type of BGP extended community called IPv4 address specific IFIT tail community. So it means it can be used by the IFIT decapsulation node to notify the IFIT capability to its partner. The IFIT encapsulation node. Because it is a traditive extended community. So we request to be allotted the subtype code number. And another one is for the IPv6 network. I think it's similarly, I mean, the similarly matter to extend the IPv6 address specific IFIC tail community. Yeah, and as shown in the figure, the original address are defined as the IPv4 address of the IFIC decapsulation node, and another one is a IPv6 address of the IFIC decapsulation node. Next page, please. Okay, this is the second optional extension to BGP next hop capability. So here, the BGP next hop capability attribute is a non-transitive BGP attribute. So here it is modified or deleted when the next hop is changed. Here we define to reflect the capability of the next hop, the hop of the IFIT capability. So here the capability codes we defined as a 2 octet assigned by binary integer, which indicates the type of next hop capability advertised and to identify an individual capability. And here we request to less code as the IFIT next hop capability. And here we also to define the original IP address as the IFIT decapsulation node address. So as defined here, we can see that a BGP speaker that can send an update with this BGP next hop capability attribute, including the IFIT next hop capability. So the including of the IFIT next hop capability with the network layer reachability information in the BGP updates indicate that the BGP next hop can act as the IFIT decapsulation node, and it can process the specific IFIT packet. Yeah, this is the second one. Next page, please. Okay. Yeah, this is all the content defined in this draft, and any comment, suggestion, questions for this draft, please let us know. And we also request work group to evaluate this draft and consider it be adopted. Thank you. That's all.
Kay, or you will need to ask for questions and manage the mic.
For sure. Any questions, folks, for Yali's presentation? Jeff? Jeff?
Am I off mute now?
Yes.
Thank you. Sorry about that. Yali, thank you for your presentation. And this, I think, is a more general question, more applicable to your draft than the one that Giuseppe has presented. I have many concerns about the security considerations and some of the protocol behaviors for this draft. Not that the problem is not worth solving, but I think there's two things that are sort of clear from looking at the initial presentation. The first one is that the IFIT domains have considerations as to how widely this information can propagate. And since these things are attached as transitive extended communities, they're very likely to get far away from where you want them to. So some discussion about that needs to happen in the draft. The second item I see is an immediate concern is when you're trying to actually say that the next hop is able to carry out certain behaviors, you're making assumptions that the next hop is potentially not being reset on a different spot of the network than where the community was originally attached. So I think that also raises concerns.
Yeah, thank you. Thank you your comments and suggestion. And for your first question, I think you mean the IFIT domain, right? How widely the IFIT domain is and how widely the IFIT information can be transmitted. Because I think the definition of the IFIT domain has been defined in, I mean, another draft, and I think we can make it aid the draft as a reference and make sure the domain of the IFIT. But as I know, the IFIT domain is defined as and bounded as the IFIT ingress node and the egress node. So after, I mean, when the package has the IFIT, IFIT header in the packet, so before before the packet transmitted to the egress nodes, it should the header IFIT header should be removed from the packet. So let's try to make sure the security in the IFIT domain, I think. But I think it should be a problem to consider it. It's
Right. The specific concern is that the communities that you're attaching to BGP will leave the IFIT domain. So let us say that ISP A is a IFIT domain and it's part of autonomous system number 1. When the routes are sent for destinations inside of that autonomous system to autonomous system 2, if the IFIT capabilities are not stripped, I believe this gives information that suggests that AS2 is capable of doing IFIT operations with AS1. I don't think the expectation for IFIT is that that should work, but the capability propagating tells it that maybe it should.
Yeah,
So,
I think, yeah, I think I will considering your suggestion. And if you don't mind, we can discuss this in the mailing list.
yes, I'll take it to the mailing list.
Thank you very much. Thank you.
Boris, you're next.
Thank you. Yali, very short comment, not question. Would be very good to see implementation status in the draft.
You mean
Version,
the time?
if you could, yeah, it would be very good.
Okay, okay. I think I will add the part in a new version. Thank you for your comments.
Tony?
Hi. Follow-up question to Jeff's comment. Given that this is local and we really don't want it propagating, wouldn't this be better served being in the management plane and not in BGP whatsoever?
Sorry, I don't catch your point. Sorry.
So why is this information in BGP? This seems like this is information that should be provided via OpenConfig.
Oh, okay. This is from the motivation. I think from the motivation of this proposal we designed, because we consider to take advantage of the BGP protocol to dynamically detect the device's capability. So we considering using the control plane protocol, not the management plan. This is our motivation here. Because here I think a previous slide we have mentioned that we considering if a devices dynamically change its capability to support the iFit application, right? So we need have a matter to dynamically detect its capability. So here we give a matter to taking advantage of the BGP protocol to catch its capability information. Yeah, that is our consideration here.
Yes, you want a protocol. I understand that. Why you stick it in routing? This has nothing to do with routing.
Okay, you mean it's relationship to the routing, right? So here I think because the you mean the iFit the iFit application can be inserted into the packet, the traffic packet. So if we want to measure the performance metrics using the iFit, I mean the IOM or the alternate marking method to get the performance metrics. So the devices need to support the capability to process the iFit packet. So when we at the ingress node, when we decide which for example, which path or the which flow we need to use the iFit application to measure the performance metrics. We need to know these devices along the path can support this capability. I mean, the support the iFit capability. So it can affect the iFit application. On the other hand, if you want to calculate a path, can be use the iFit application to measure the performance metrics to make sure the SOA of this path. So you need to know how which devices cannot support or which devices can support the iFit application along the path. So
Yelly, this is Sue.
yes.
I think you might I think you might need, before working group adoption, to carefully consider Tony's question and provide some pros and cons on this. I don't think at this point, perhaps due to the fact you've just heard Tony's question, that you've given a response that doesn't point back to the management plane. So may I kindly suggest that you consider this question with your co-authors and provide some additional details. If you'd like some feedback on an initial presentation before you send it to the list, you are welcome to send it to the chairs. But I think it would be wise to consider and give pros and cons before you go for a working group adoption. Otherwise, I think we're going to go through this discussion again. Would that be okay, Yali?
Yeah, sure. I want to discuss more details with yours.
Yeah, or you can, I encourage you that this discussion should will need to occur on the list before working group adoption. But if you are unclear on the question or the import of the question, you can, of course, send the chairs some clarification, but you will need to discuss why this is important to put in routing on the list before we go working group adoption. Otherwise, I'm afraid it will just repeat during working group adoption. Do you understand what I'm saying? If not, you can ask me in email.
Yeah, I think I got your point.
Okay.
Yeah. Thank you.
Thank you again for your time and for your presentation.
Thank you.
Think we're out of time, Kare. It's your
Yep.
call.
Yep. No, why don't we take your questions, Robin and Giuseppe, on the mailing list and close the presentation at this point. Sorry and thank you. So that was the last presentation, and we will see you again at IETF 111th in 3 months. Thank you, folks.